Sorry to intrude into your conversations, and it's always fantastic hearing the buzz that comes with a LEAP conference. Welcome to Oxford once again. I'm Susan Jebb. I've been co-director of the LEAP project with Charles Godfrey, who you'll hear from later this afternoon. And it is a huge highlight of our year to host this event. It's, I think this is the 6th year. I think this is the 4th in-person LEAP conference, and we had 2 online. And it's brilliant that there are many. In fact, how many people were here at the first LEAP conference at St Anne's? That is pretty good. That is pretty good. Is there anybody who's been to all of the LEAP conferences? Oh, gosh, we've hung on to those people who came to the very first. I feel like we should give you a badge. So thank you for being with us. Thank you for contributing to the project. Thank you for all you've done, really, to develop this whole area of research. And my goodness, it has come on in leaps and bounds over the time we've been doing this project. As most of you, I think, know, the funding from Wellcome, which established LEAP, has come to an end. I am delighted that, I'm obviously very disappointed about that, but I'm delighted that actually many of the investigators who are working within the project have been able to secure other funding. And so much of what we have done within LEAP will continue in various other forms. And I hope that this sort of community of researchers who've come together will also find ways to continue to connect in the coming years. But it's not over. In fact, it's only just beginning, and really looking forward to the meeting today. Before we get into the science, it falls to me to do my housekeeping bit. There are no fire alarms scheduled. If the fire alarm goes off, there are 2 exits up behind you, my air hostess bit, and you should assemble on the grass outside. It's probably also the flight duty to remind you to turn off your mobile phones, or at least put them on silent. Mostly the sessions will be in here. You can see, you've probably found the posters, which are on the other side of reception. And when we break into parallel sessions, the other room is the Talbot room, which you do need to go outside and across the quad. It's essentially diagonal to here, but it is well signposted, and there are people around who can help you. There are cloakrooms effectively behind reception, and there are some the other side of the quad. So hopefully that's enough information to help you get through the day. There'll be refreshments and lunch as we go along. I'm trying to now think, was there anything else I was supposed to tell people? I think that's probably it, but if there was anything more, somebody will prompt me and I'll tell you later. So let's, without further ado, crack on with the science. And I'm absolutely delighted that our first plenary speaker today is Lindsay Jaacks. So Lindsay and I have known each other for 10 or 15 years, maybe even more than that. Anyway, quite a while. Lindsay's a nutrition epidemiologist by background and had a long-standing interest in non-communicable disease, working on a very global basis with projects really around the world, particularly at the moment in India. I was thrilled when 5 years ago, perhaps, she was tempted across the pond and moved from North Carolina to the University of Edinburgh. And it's been brilliant to see her work there go from strength to strength. And just this morning, she told me that in addition to her previous role there, she's now also become director of Earth Initiative Edinburgh. So we look forward to all the work that will come out of that new centre. Lindsay's work's sort of a little bit like my own in a way, in the sense that it's moved on from non-communicable disease and very much focused on diet, particularly in relation to obesity and related conditions, but has really stretched into environmental sustainability and into agriculture. So she's got quite a bit of work now in that space, including a big project on pesticide use in India. But today she's going to really bring several of these interests together with her talk, which is going to focus on this really challenging question about what is the optimal meat and dairy consumption, and can we balance health of people with health of the planet? Is it possible indeed to implement the notion of optimization? So Lindsay, thank you for making it from Edinburgh down to the other side of the border and joining us today, and really looking forward to your talk. Thank you.
Great. Well, thank you so much, Susan. It really is an honor to be here today to give this keynote. And people are saying that it's going to be the last leap or the final leap, and I hope that that's some April Fool's joke and that we'll all be back here again next year. It really is an amazing, energizing community, and I would say that we're really just starting to get started on the shift to sustainable diets. So as Susan mentioned, I've been given the very easy task of presenting all of the research on the health effects of meat and dairy in 30 minutes. So you'll have to bear with me today. I'm definitely not going to cover everything, but if you have questions, I've already planted a question about bone health up at the back. Feel free to ask them. I'm happy to speak to other outcomes that I won't cover today. So in terms of this topic, I would say that the role of animal source products in our diets is perhaps one of the most polarized areas. I was going to say in nutrition, but I would say that that's like broadly in sustainable diets and sustainable food system transitions, and even maybe within the sphere of climate change. I mean, meat is a very polarizing subject. So here at LEAP, in this community, I'd hypothesize that most of you think if you ate a ham sandwich like this every day for lunch, it would probably increase your risk of colorectal cancer. However, if instead of being here at the LEAP conference, you were instead at the British Society of Animal Science last year, as some of my colleagues up in Edinburgh were, you may strongly disagree with this. And instead, you might believe that red meat is essential for the growth and development of children, that there is no scientific evidence linking high meat intake to increased risk of mortality, and that nutritionists who believe otherwise need to be more diligent in their research on these matters. So my question is, which is it? Are we increasing our kids' risk of developing colorectal cancer by sending them to lunch, a ham sandwich for lunch every day? Or are we delaying their growth and development by sending them a peanut butter sandwich for lunch every day? And I have the very unsatisfactory answer to that, which is that it depends. So it depends on what they had for breakfast that day, it depends on what else they had for lunch that day, and what they're going to have for dinner that night. And so what I'm hoping to kind of convince you in this 30 minutes or so is that in nutritional epidemiology, we really need to shift from linear thinking to systems thinking. So when I learned nutrition epi at UNC, we were very much talking about exposure outcome. Is a ham sandwich related to colorectal cancer risk? And I think we need to really shift to thinking about the whole diet, because it's the whole diet that actually influences the colorectal cancer risk. So here I'm showing a snapshot from one of our participants in a national diet survey that we're running up in Scotland for Food Standards Scotland of a 6-year-old a couple weeks ago. And this 6-year-old lives in one of the most deprived areas in Scotland. So you can see here that they not only had a ham sandwich, might I point out also on white bread for lunch, but they also had a relatively high sugar diet covering both the breakfast, the other things they had for lunch, and the snack they had for dinner, which included actually a soy milk, which some of us might be interested in here. So if this reflects the usual diet of this 6-year-old, regularly eating processed meat, not only for lunch, but also for dinner, you can see they had pork sausages for dinner. if they continue to eat this, and this is their usual diet over time, it may increase their risk of getting cancer when they get older. But whether getting rid of that ham sandwich and putting a peanut butter sandwich into that diet reduces their risk of getting cancer as an adult actually depends on all this other stuff in the diet. You may not see an effect of putting a peanut butter sandwich in there if you don't change these other things. And so we really need to think about systems, the whole diet, rather than just the ham sandwich. So I'll present some of our group's research on how I got to this conclusion, including some more work that we've been doing up in Scotland for Food Standards Scotland. But the main implication, I would say, is that the sustainable diets community, such as those in this room, really need to get serious about fixing unhealthy diets as a whole. And yes, I 100% agree that we need to reduce both meat and dairy if we're going to address the climate impacts of diet. But if we're serious about tackling diet-related inequalities at the same time, we need not only to replace the meat and dairy, but we need to replace the refined grains in these diets. We need to replace the high-fat, high-sugar, high-salt snacks in the diets, and ideally replacing these with whole foods, fresh fruits and vegetables, nuts and seeds, and whole grains. So let's dive in. I'm coming from Edinburgh, and some of you may have actually seen this if you've been to a museum up in Edinburgh. But it's a bit of nutrition history that's quite interesting. So James Lind, who published this paper, was a Scottish physician, and he's often credited with conducting the first controlled trial, which was back in May 1947. So in this trial, Lind assigned 12 men with scurvy to one of 6 treatments for a duration of 2 weeks each. And those treatments ranged from things like cider and diluted sulfuric acid to oranges and lemon. And of course, everyone knows the conclusion of that trial, which was very conclusive in that there was really an immediate effect of the citrus fruits on the health of the sailors who received that. Within a couple of days, one of them was fully cured, and the other one was well enough that he could take care of the other sailors. And of course, this discovery improved occupational health for sailors, but it also facilitated colonialization by reducing morbidity and mortality on long sea voyages. But beyond vitamin C, this story can be told for many, many other micronutrients, whether that be the B vitamins or other vitamins like vitamin A. And it's really this type of history that contributes to this paradigm that we see today, which is very relevant when we think about meat and dairy, that randomized controlled trials are the gold standard for generating knowledge in nutrition, and that if a randomized controlled trial doesn't show an effect, then an effect must not exist. And so this is kind of the prevailing paradigm within nutrition research. So to bring us back to meat, probably many of you recognize this infamous issue of Annals of Internal Medicine back from 2019. This was the one that included the 5 review articles in these so-called clinical guidelines for red processed meat and unprocessed meat. And it was the one that kind of led to all these news headlines, you can eat all the meat that you want out there. And so the reason I bring this issue up is that it very much came to that same conclusion. There are not randomized controlled trials that support an effect of meat on health outcomes, and therefore there is no effect, and you can carry on eating all the meat that you want. And to quote the editorial that actually accompanied these articles, because I think it's quite interesting, and if you're a nutritional epidemiologist, it may sit unwell with you. But the editorial said, the field of nutritional epidemiology is plagued by observational studies that have been conducted inappropriately, accompanied by likely erroneous conclusions. Many studies selectively report results, and many lack a priori hypotheses. Many use notoriously unreliable self-reports of food consumption, something I will come back to later, while failing to collect or appropriately control for data on numerous potential confounders. So, it really kind of said, again, that we need randomized controlled trials. So I'd like to just think about, okay, let's conduct a randomized controlled trial of the effect of processed red meat, for example, on colorectal cancer. what would that trial look like? Well, the incidence rate of colorectal cancer or bowel cancer here in the UK is 69 cases per 100,000 people. I spent way too much time doing a power calculation for that, but basically you need at least twice as many of those cases in the trial to be well powered to detect an effect of processed meat on colorectal cancer. So you'd be looking at recruiting and retaining over many years more than 200,000 participants to be in that trial. I don't know if any of you are aware of how many participants were in the largest dietary trial, the Women's Health Initiative, but it was shy of 100,000. I think it was around 75,000 participants. And so we're looking at conducting the largest trial by more than double of the previous largest trial. And I think what's important to think about, again, is that that type of trial would contribute to this linear thinking, processed meat on colorectal cancer. And really, if you were designing that trial well, you would have to decide very carefully what the control group would eat. Would they not eat anything in place of the processed red meat? Would they eat legumes, pulses? Would they eat a plant-based meat alternative? And you'd only be able to test one of those substitutes to have a really kind of gold standard trial. So you'd only be able to answer, what is the impact of substituting plant-based processed meats for regular processed meats on colorectal cancer after 10 years, 200,000 participants, and tons of money. So this will just absolutely never happen. And I don't think it should happen because, again, it just contributes to this linear thinking in nutrition epidemiology. So this brings me to some of the work that we've recently conducted for Food Standards Scotland. And I'm not going to present all of the details in this report. I would encourage you to check it out online if you'd like to learn more. And a shout out to Joe in the back. He's going to be presenting later on some of the simulation results from this report. But I wanted to start out by just showing some of the headlines because I think it's quite interesting and further supports some of the conclusions of the Annals of Internal Medicine reviews, which came to this conclusion you can eat as much red meat as you want, using the same underlying data and studies as other reviews that have concluded exactly the opposite. And the same thing here. So this is one report with very different headlines. Some articles were talking about how we really need to reduce meat to tackle climate change in Scotland, and others, including quotes from Quality Meat Scotland, were saying, we really need to be careful about reducing meat because it's going to pose health risks. So wide variability in how people were interpreting the same results. But basically what we set out to do in this report is to look at the impact of reducing meat and dairy according to the Climate Change Committee recommendations, which is a 20% reduction in both meat and dairy, all meat and dairy actually, in the population. And we were able to look at, in this study, just adults 16 years and older. As I mentioned, we're currently collecting data on children in Scotland, and we'll be repeating the same analysis for children and young people. So in this report, we were looking at what's the current status of nutrient intake and meat and dairy intake in Scotland, and what would it look like if we followed these recommendations. Before I present the results, I just want to come back to a point that I made earlier, which I agree with. And that is that we really do underreport in self-reported dietary surveys. So the survey we use in this report is the Scottish Health Survey. This survey includes up to 2 24-hour dietary recalls, and about 85% of people in that survey completed 2 recalls. So most of the sample has these 2 recalls. But in that, if you take the average energy intake, it's about 1,630 calories a day. And here I'm just showing recommended intake for a moderately active adult male. It hovers around 2,500 calories a day. And so we're underestimating by about a third what people are eating in Scotland. And this is not just true for Scotland, of course, also in the National Diet and Nutrition Survey, that's a UK-wide survey, there's also significant underreporting. And this underreport is about a third compared to that recommendation, but of course we know that about 70% of adults in Scotland have overweight and obesity, which increases the calorie requirements, and so we're probably underestimating by even more than that third. The issue here is that we have no idea what's in that gap between what is being reported and what is probably what people are actually eating. So we don't know if that gap is there because people are just reporting smaller portions than they're actually consuming, or if they're just completely leaving foods out. And if they are completely leaving foods out, we don't know what those are. So the gap could be beef and spaghetti bolognese, or it could be carrot sticks, or it could be chips or crisps. We don't know what's in that gap. And so there are two major implications of that gap for the findings of this report. The first is that we are definitely underestimating intake of nutrients. If you're missing a third of someone's diet, you're missing a third, well, depends on what they're underreporting, but you're missing some of the nutrients that they're consuming. And then the implication of that is that we are definitely overestimating the number of people at risk of insufficiency. Because we don't have all the nutrients that they're consuming, we're kind of overestimating whether or not they're at risk of being below the recommended intake. And so what I'm presenting is the worst case scenarios. And the reality is probably a lot more optimistic than what I'm going to show. And I think that that's important to keep in mind to kind of prevent this fear-mongering around if you reduce meat and dairy, all these people are going to become deficient in nutrients. And unfortunately, as you saw, the headlines did not get that caveat very clearly. So what did we actually find in this? Well, what we found first and foremost is that most people in Scotland consume some meat and dairy on these 2 days. For dairy, it's 99%. For meat, it's 86%. And you can look at this in two ways. One way is, well, if you reduce meat and dairy, a lot of people in Scotland are going to be impacted. And a lot of these news articles did mention that. The other way you can think about it is, well, there are lots of opportunities for reducing the climate impact of diets in Scotland because a lot of people consume these high impact foods. In terms of looking a little bit more closely at that consumption, about 25% of the meat in Scotland by weight is beef, and about 14% of the dairy is cheese. And the reason, of course, I highlight these two things is that these are the highest intensity types of meat and dairy in diets. And just to take the example of cheese, cheese accounts for 14% by weight of dairy in Scotland, but it accounts for about half of emissions from dairy, just given how much higher the emissions are per gram of cheese. And so in terms of the contribution of meat and dairy to nutrient intake in Scotland today, so this is not projecting for the Climate Change Committee recommendations, but current intake levels. I'm showing the results here for 6 key nutrients, but Christina Stewart, who is somewhere, has looked at 27 nutrients. So if I'm not showing one of your favorite nutrients, find Christina, and she can tell you about vitamin A or something. But what I want you to focus on in this slide is actually not what's in red, which is the meat, or blue, which is the dairy, but the dark gray, because the dark gray is everything else in the diet. And so what you can see is that for a lot of things, iron, for example, which people often talk about as being a key nutrient when you think about meat and dairy, actually most of the iron consumed in Scotland comes from other things, particularly fortified grain products. But also, things like selenium, there's a large proportion of these key nutrients coming from other stuff that's not meat and dairy. Of course, there are exceptions. So take B12, which is another nutrient people will be aware of probably if you study vegan diets. 38% of B12 in Scotland comes from dairy products. And when it comes to zinc, 24% from meat. So this is kind of how meat and dairy are contributing to nutrient intake currently. What does this mean in terms of deficiency? So I think it's important to point out that, yes, we have this underreporting and self-reported data. we have some biomarkers of nutritional status. So these are kind of closer to a clinical nutrient deficiency that can result in, for example, with iron deficiency, fatigue, and other outcomes. And these are not measured in the Scottish Health Survey. I've pulled them up from the National Diet and Nutrition Survey, so these are UK-wide estimates of these deficiencies in adults. And what you can see here is that deficiency levels are actually relatively low for some of these things. And some things may surprise you. For example, iodine deficiency, upwards of 20% for women. So actually more women are deficient in iodine than iron. So I think it's kind of important to point these numbers out before I point out the nutrient intake relative to recommended nutrient intake. So keep kind of these numbers or the ballpark numbers in mind. So this slide is just showing what happens in one of the scenarios. And I think we did close to 30 scenarios, maybe more. So definitely check out the report if you're interested. But here I'm just kind of focusing on that original Climate Change Committee target of a 20% reduction in meat and dairy. And the blue bars here are what current nutrient intakes are in terms of the proportion of the population below the RNI, which is the recommended nutrient intake. And so that cut point is basically the amount of that nutrient that you need in order to be adequate for 97.5% of the population. So it's a very conservative estimate. But what you can see is that the proportion of the population below that cut point in Scotland is relatively high. But again, this is not the proportion of the population that's deficient in a clinical sense, like those biomarkers on the previous slide. This is just based on 2 days of intake relative to that conservative cut point. And what I plotted in green is what happens if you adopt the Climate Change Committee recommendations. So there is this slight uptick in the proportion of the population who drops below the recommended nutrient intake. And you can see that I've just kind of highlighted here the couple of nutrients that are really important when it comes to meat and dairy. So calcium, iodine, zinc, you may remember from the pie charts, were really important when it came to meat and dairy. And you do see bigger increases in the proportion dropping below for those nutrients when you reduce meat and dairy. So not super surprising. So what happens if this is just reducing meat and dairy, but what happens if you replace meat and dairy with other foods? We have also modeled that. So here I'm just showing same thing on the y-axis. So this is the percent of the population that's below the recommended nutrient intake. And you can see all the different substitutes. So the current intake, no substitution, which I was on the previous slide, is in black. And then various other substitutes: beans, vegetables, egg, oily fish, plant-based meat, and chicken. And for all of these, we replace the dairy with plant-based dairy alternatives. So you can see, just comparing the black bar with no replacement to the colorful bars on the other side of that, that you can kind of attenuate that slight uptick in the percentage that drops below the RNI by targeting nutrient-dense substitutes. Is this what's going to happen if you implement policies to reduce meat and dairy? Are people going to all of a sudden start eating vegetables and beans? I don't know. There's not much evidence on that. And in fact, a paper that we just published yesterday in the US showed that if you put warning labels or taxes on red meat, actually what you see is people start eating cheese and processed poultry, which is supported by some of the kind of longitudinal trends in animal source product intake as well. So not sure. I mean, that's why we added chicken here, because that probably is a more likely substitute if you focus on red meat in particular. But you can attenuate the effects. I think one of the things that was most surprising in this analysis for a lot of people was the egg substitution, because eggs do have a lower carbon intensity, and they also fared pretty well in terms of attenuating that impact on nutrient intake. So that's kind of talking about the Food Standards Scotland report. what I think the implications of this are is that we need to go beyond thinking about just these animal source products, but the substitutes that are put in place. So many of you will be familiar with this analysis of the Harvard cohorts, the Nurses' Health Studies 1 and 2, and the Health Professionals study. Over 300,000 participants followed for over 30 years. You aren't going to get observational nutrition epidemiology much better than this unless you can create a time machine and go back and set up some cohorts. And they published this study, which was really interesting in that they split out and created 2 indices. One was healthful plant-based diets, and one was unhealthful plant-based diets. And so again, it's thinking about not just the animal source products in these diets, but all of the plant-based products that they're consuming. And what they found is that only the healthy plant-based diet was associated with a reduced risk of diabetes. So basically, you can have a plant-based diet that's fit for health and actually has no impact and could be harmful, actually. And so I think it really just captures this need to shift in nutritional epidemiology from thinking about meat and diabetes, for example, to thinking about the whole diet and diabetes risk. And I think this really does need to be reflected in the policies and the actions that we take as well. So I've kind of also been given the task of briefly speaking to how can we shift towards these lower meat, lower dairy diets. And I would say broadly, I'm kind of trying to think about how to shift towards healthier diets overall, not just reducing the meat and dairy, but encouraging these substitutes, like on this slide, encouraging these healthy substitutes for these products so that the whole diet improves. And a colleague of mine reminded me of the North Karelia project. I'm not sure if people have heard about this because I don't know if they still talk about it in nutrition epidemiology classes. But this was a very famous project that was done in the 70s and 80s. And it's interesting because part of this project included a dairy to berry project where they worked with local food producers to encourage a shift from dairy production to berry production. And maybe I should actually rewind a little bit to just mention a little bit of history of that project. Basically, Finland back in the 70s had the highest cardiovascular risk in young men. Young men were dying very young in their 30s and 40s from heart attacks and strokes. And so the Finnish government said, we need to address this and do something quite innovative. Interestingly, at that time, the same study that showed that Finnish young men had this really high cardiovascular risk, Scottish young men were just behind them. So it would have been nice to have seen something like that happen in Scotland back in the 70s. But anyway, so this happened in Finland. They sent out a young and very motivated epidemiologist into these communities to set up this project in 1972. And they also set up really rigorous monitoring. That was almost part of the intervention because they provided those results to the villages over time so that they could see how they were doing. But it was really a landmark study in terms of a community-based approach to prevention. I will note that I'm not aware of anyone who's ever replicated this anywhere else in the world. If you're aware of something, let me know. But it was quite a unique study. And there were a couple things I think that made it successful. One, of course, was that champion who was sent out to work on this and really do a lot of knocking on doors and going to pubs and talking with people. But the other thing is that it took a whole systems approach. So as I said, they were not just focusing on individual behavior change. Yes, there were a lot of cooking classes, and that's always the first thing people want to do when it comes to community-based prevention. So they did do that, but they really worked a lot on the underlying food system. So working with farmers to try and train them working with dairy farmers to try and train them in berry growing, providing subsidies, providing processing equipment so that they could freeze the berries or turn them into high sugar jams and things, but to enable year-round access to these fruits. And it's interesting because they did see substantial shifts in diet. I mean, if you want an example of where diets have shifted in a 10-year period, it did happen here. Dairy dropped dramatically. That was milk and butter. Meat went down, vegetables went up, fruits went up. So there was a big shift in diets, and as a result, there was a big drop in cardiovascular risk. There was, of course, also an emphasis on smoking, and smoking also went down. But a lot of the evaluations have said that it was both that decline in smoking and the improvements in diet that led to the improved health outcomes. So I think this is a good example. It's not been replicated. I don't know that that approach entirely would work today, but it reminded me as I was rereading those papers from the 80s of this evaluation, it reminded me a lot of a project that we're doing on behalf of, or in support of Scottish Government with funding from Wellcome up in Scotland. Some of you may have heard of this National Good Food Nation Plan. This was an act that was passed in 2022, so a couple years ago now. But the draft National Good Food Nation Plan was published earlier this year, and we have an analytical hub that's been set up to do some of the monitoring for that. And the nice thing about the Good Food Nation Plan in Scotland is that it again tries to take this whole systems approach. And it's also a combination of a top-down and bottom-up model. So it's a national plan, but also all local authorities and health boards in Scotland have to have their own plans and plans of action to actually implement and deliver them. I would say the big difference between Scotland and this North Karelia project is resource, which won't be surprising. So in the North Karelia project, Pushka had a project lead in every village, funded by the central government to actually take the plan forward. In Scotland, I don't think there's been any funding committed to the National Good Food Nation Plan in terms of local implementation. So that is definitely a major challenge. But I think there's some hint that maybe in Scotland we're going to have something similar to North Karelia in 10 years. So if we can keep the LEAP conference going for that long, hopefully I can come back and talk about that. A final slide, as I was thinking about, what can we do? Where have diets shifted? And I was kind of reminded that rich people in lots of places eat healthy diets. And so if you've heard me talk about some of the local levers work we do up in Scotland, the first thing I always say is the most important local lever, or lever at all when it comes to diets and healthy weight, is poverty. And so I'm really glad that actually one of the key indicators for the National Good Food Nation Plan is the proportion of children living in poverty. And this is just some of the data that I put together for Scotland. But if you look at meat intake, this is a percentage of adults who are low consumers of red meat. This is both unprocessed and processed red meat. You see a clear difference between the most and least deprived parts of Scotland. So people in the least deprived parts of Scotland eat more of this of red meat. They're less likely to be low consumers. And if you look at other health-related outcomes, such as obvious tooth decay, you see, again, this really clear divide between the least and the most deprived kids in Scotland. And so I think that really, if we are serious about shifting a whole population to healthier diets and healthier sustainable diets, we can't do that without addressing poverty. So I'm going to leave plenty of time, hopefully, for questions. But before I get to that, I just have lots of acknowledgements and apologies. I'm sure I'm leaving someone out. But all of this work was done with a really incredible team, many of whom are here, I think all sitting in the back row there. So many thanks to all of our collaborators at University of Edinburgh, here at Oxford, and elsewhere. So thank you.
Lindsay, thank you so much for that. You packed a huge amount in, and I think it is, people get very downhearted about dietary change, and I think it was great to be reminded of the North Karelia project. And I think it shows that, you know, if you put big effort in, big things can happen. And I think we often fall into the trap of thinking that, you know, okay, well, you know, people like to say, oh, small changes can lead to big results, but in general, small changes have small impacts. And you need an awful lot of small changes if you're going to make a difference. So thank you so much for that. I'm going to open this up if there's anybody who has any questions. Whilst you're thinking, I just wanted to take you back to that whole issue of Annals of Internal Medicine. And the thing that really struck me is I think they came up basically saying there was about a 17% increased risk. And when I look back, that was almost exactly what Global Burden of Disease, other people had said. And it struck me that what this comes down to is whether you think a 17% increase in risk is something you should care about or not. And that this isn't actually about the underpinning science. It's simply about your risk appetite. And I'm not sure we talk about, you know, somehow this all gets reduced to being scientists disagree, whereas in fact for me it's much more about interpretation of the science.
Yeah, absolutely. And I think also even the grading of the quality of evidence, if you look at that review and a review published a year later, it's the same exact 12 trials that were included, same exact grading of evidence, but again, just a different concluding sentence in the abstract, basically. And so, yeah, it's just polarized. It's a very polarized space. And I think that the way out of that, so I have an interesting hat since I left schools of public health for my whole career and moved to the Global Academy up at Edinburgh, because we're actually in the vet school. We sit in the vet school like where they clone Dolly the sheep. And so the first nutritionist I met there, I was like, oh, great, he's an animal nutritionist. And actually, they've done a lot of really great studies, and they know more about micronutrient requirements in animals than they do in humans. And so it's been interesting because we've had, I feel like we aren't polarized, actually. We have, I think, come to realize they accept that it needs to change. We accept that there's a role. We're not advocating for vegan diets. And I think that we've kind of found this ability to have open dialogues, which has been really nice, I think, for us. But you know, and that's how I found out actually about this conference, and we were able to respond together to that newsletter in a very thoughtful, evidence-based way. So I think it's starting to have those conversations and bringing people along with us that's really going to be required rather than contributing to a continued polarized debate.
Thank you. Teresa, you want to speak loudly? Or?
I can speak loudly.
Yeah.
Thank you very much, Lindsay. Teresa Marte, University of Cambridge. It was an excellent talk. And I have an interest. I'm a commissioner for eLancet too.
Yep.
And I was interested that you didn't mention eLancet, which was first published in 2019. There's now a second variant of it, where it described a planetary health diet, not unlike what you were talking about, at global level, talking about halving the amount of meat and the amount of sugar, doubling the amount of vegetables. And we're now looking at how we might have people adopt that. To what extent do you think it would help if we were all talking about a diet in the same way, sort of branding? So I'd just like you to, I'm not criticising you for not having that. I have an interest, so at the moment,
Of course, yeah.
How does that map onto?
Yeah. So I think for this, I assumed for this audience, Eat Lancet is a well-established thing, so it wouldn't be new and exciting, and I was trying to catch people's attention. But I think that kind of going back a bit to this polarization, I advocate a lot for the Planetary Health Index, and our team has done a lot of work in monitoring adherence to the Eat Lancet in the US and in Mexico with some of Kayla's work. So I think it was a brilliant idea, but unfortunately it has led to this polarized situation. A lot of the meat sector has kind of taken it up and created this polarized space. And so I think that, and I would say also from a local perspective, even thinking about the Mexico situation with some of Kayla's work with INSP, the Mexican dietary guidelines basically map clearly onto the planetary health diet from Eat Lancet, but it's easier to talk about the Mexican dietary guidelines because it's not as polarized, I would say, in some contexts. So I don't know, like I think there's definitely scope, and I think the really valuable thing for Eat Lancet in particular is that it gave us these, it quantified it, it put numbers to it, and that was a really hard process, but I commend that because actually that helps so much when we think about setting targets and monitoring and things like that. So I'm really appreciative of that, but I think that from a implementation standpoint, if you can tag it as Mexican dietary guidelines or US dietary guidelines, I mean, we're a long ways from getting there in the US, but maybe in the next round. You know, that I think is really valuable.
Dying to jump in on that. I can feel a whole debate coming in as to whether or not having this universal diet is helpful or not. I'm not sure I agree with that.
Well, it's not a universal diet. But
Anyway, we'll debate that another day.
It's not well communicated.
Yeah.
Yes. Yeah.
Tim Key, Oxford University. I just wanted to talk a bit about your point about, you started with meat and colorectal cancer.
Yep.
And then you went on to talking about the linear
Yeah.
exposure causes disease. And I think you've picked on a sort of interesting example where the problem is we don't understand whether or how meat causes colorectal cancer. And I think there are other examples. I mean, you mentioned scurvy,
Yep.
where it is linear. You've got a
Yeah.
chemical. You could take orange juice, you could take a pill of vitamin C, it
Yep.
works. And there are other examples related to meat, like sodium and saturated fat, where there's always somebody who disagrees, but
Yeah.
generally people think salt causes high blood pressure, causes stroke, etc.
Yeah.
And it probably doesn't matter whether the salt's in bacon or crisps or whatever. It's the total amount you consume. And therefore, meat would be one component, then you could work out the sums.
Yeah.
Saturated fat, there's more argument about that.
Yep.
But you can say how much saturated fat is in meat and what effect quantitatively there is on LDL cholesterol.
Yep. Yep.
But I think the problem with colorectal cancer, although we've been working on this with people all over the world for 40 years, it's really not clear what the mechanism is that links diet to cancer.
Yeah.
And some of the data on meat is really not clear,
Yeah.
which obviously the meat industry are quite interested in pointing that out.
Yeah.
So I don't know what my point is really. I think sometimes there is a linear
Yeah.
effect.
Yeah.
The meat colorectal, I sort of agree with you that it looks as if it's not actually clear that it's meat. Maybe it's the microbiome and meat and fibre and all sorts of things that contribute to meat which can be bad.
Yeah. Yeah.
But I think everyone's struggling with the meat colorectal because we don't understand the actual intermediate mechanism.
Yeah, I mean, I think that there's some risk here of if meat is associated with cancer, there's some risk of trying to find out what it is within meat. I'm just going to talk about fruits and vegetables as an example. So there was people had observed in observational studies that fruits and vegetables were associated with reduced risk of disease. And so they thought, oh, well, maybe it's beta carotene or something like that that's associated. So then they set up a big trial where they give people beta carotene pills, and in smokers that increases their risk of lung cancer. But it's not that fruits and vegetables do that, it's maybe high doses of beta carotene. So I think that when we move from thinking about specific nutrient deficiencies to foods, the foods themselves are so complex that I don't think trials that test a specific component, so people have implicated heme iron, for example, as one of the potential carcinogenic aspects of meat for cancer. But I don't think a trial where you give people heme iron pills, I mean, you won't be able to do it as a pill, but actually maybe Impossible Foods because they're making heme iron in use. But a heme iron trial I don't think would be worth funding because it's probably, as you say, this interaction between all of the components of meat. But even for salt, there's a lot of evidence now that it's the salt-potassium ratio, actually, that's important. So, there have been a lot of trials that reduce salt and don't see an impact on hypertension, but it's probably the potassium-sodium ratio that is linked. But I'm not a salt expert, so others can maybe comment. But it's a good point.
Oh, there's a whole raft of questions. I'm going to take three. Let's 2 quick questions at that, but let's keep them quite tight. So the late, yeah.
Thank you very much, Lindsay. That was great. Totally agree with you that we need a whole systems approach to nutrition epidemiology as opposed to a linear way of researching. And I also find the gap between the self-reported nutrition and the average huge. I guess my question, it's a purely selfish question as an early career researcher, from your perspective, what do you think would be the most useful methodological approaches to facilitate this systemic approach to information or dietary shifts?
Yeah.
I'm going to take a few questions in the back so we get them through. Yes, the late.
Yeah, so
Yep.
my question is about the data that you showed on micronutrient deficiencies.
Yep.
There were no error bars, so I don't know what the
Yeah.
confidence level is.
Yep.
I mean, is 90% selenium to 92% selenium, is that significant?
Sorry, do you want to?
I think we can just give you those later. That's
Yep.
probably the easiest thing. The lady just in front of you. Yeah.
Yes, thank you very much as well from my side. I've got a question which is kind of related to those 2 questions before. So you said you had all those survey data and you found deficiencies, but one other way of thinking it around would be like if we have data we know that is falling short in terms of what is taken in, we could also look at overconsumption of certain, I don't know, nutrients like, I don't know, salt or like, I don't know, fatty acids, whatever.
Yep.
And because then we're certainly on the safe side, right? They're underreporting stuff. We know that the amounts they're
Yep.
reporting is definitely higher than that. So was there any look into that or not?
So 2 about data reporting,
yep.
and then there's 2 ladies at the front here, one, and then there, and then we're going to stop.
Mine is to do with life path. I know you're doing some work on children right now.
Yep.
Obviously, nutrition through life has different requirements, and that layers yet another complexity. And we need to, and I studied nutrition at some point, very far away in my life, and I always think we need people to understand there isn't such a thing as the perfect diet. Even if I know all my genes, my life will change, and what I need will change through life. So the oversimplification even of the question, if you like, is probably a challenge.
Yep.
That's one question. Thank you. Yes, so it was sort of because of your inclusion of media and not just research but how it's disseminated. I was wondering what you want to see scientists' role as in disseminating complex research versus sort of the inevitable dissemination by popular media. Because I suppose, as you've really well talked about, there's such nuance in these findings. But I also think because it's inevitable that media will pick up on headlines and things, what do you think scientists' role is in, despite those nuances, creating sort of those clear conclusions if we're actually looking to educate the public?
Yep.
Great question. So 3 nutrition epidemiology ones, which we're going to do really briefly, and then
Yep.
I think a great point to close on is what's our kind of responsibility. Most people, not wholly a scientific academic audience here, but probably most people are, so I think that's kind of a great point to end on.
Yep. So just quickly on the salt and trans fat thing. Salt, unfortunately, is not something that is good for self-report. And that's not just because of self-report, but the underlying food composition databases that we use. So most people don't accept self-reported dietary data for salt, and they use the 24-hour urinary sodium. So NDNS, the National Diet and Nutrition Survey, does have that, and that's how we monitor reformulation and things like that. If you look at self-reported salt intake, everyone's meeting the Scottish Dietary Goal, basically. It's the one everyone's really doing well on. But of course, we know that's not true. In terms of the gap, I would say that understanding that gap in reporting is probably the single most important thing that we need to address in nutritional epidemiology in the UK. And that is because it really will influence the carbon footprint of diets if we move to a consumption-based approach of monitoring emissions, and which I think we should be. So we're trying to think about that. I'm meeting up with some people in August to have a think about it over a long weekend, but we don't really know how we're going to figure that out. There have been some really interesting studies where they bring people into a lab for 4 weeks and measure everything that goes in and everything that comes out and things like that. And but no real-world studies that have tried to look at that. And I think that mobile phone AI-based diet assessment maybe could play a role in shedding some light there, but we really do need to understand what that gap is. And then in terms of the life course, I agree. I mean, of course, nutrient requirements will change as kids grow. And different life stages in terms of reproductive health and things like that. And so I think that it's clear that we have different guidelines for different life stages, and we always analyze our data relative to those specific life stages, which is important. But I think that it will be interesting to see what these reductions do, particularly the dairy reduction for kids, because I imagine all of those bubbles for dairy will be much bigger when you look at children and young people. In terms of our role in communication, I mean, I think that you can't control like these types of articles that come out. If you publish something, this type of stuff will come out, and you can't really. None of those reporters talk to any of us. They just kind of put those out there. I do think there is a role. I mean, a funny story that I tell recently, and I was just at a wedding last weekend, and it came up again, which is so embarrassing. But someone from BBC called me randomly in my office, and I picked up, and I was chatting with them about this Mr. Universe person was from Scotland this year, apparently. And so he switched from a high protein diet to a high carb diet, and he claims that that's why he became Mr. Universe. And so I was chatting with her about the role of protein in diets and how everyone is obsessed with protein, and actually we're all perfectly sufficient in protein, and you don't need to take all these protein supplements and things like that, diverse diets, et cetera, kind of standard nutrition advice. And everyone has been asking me about this article, and and it has been like maybe the most high impact thing I've ever done. And it just, I guess, is an example of like, I've been saying that for decades. And it's not until someone writes a Mr. Universe article in the BBC that goes viral that actually that message comes across. And even my brother in the US was like, who's a bit of a gym bro is what I would call him. He was talking about, my clean diet, which is a plant-based diet, but it's called a clean diet. And so it's kind of coming across, but in a weird path. So I do think there's a role for that. You never know. It's important to kind of be consistent in your messaging over time, and to take those kind of weird opportunities when they come, because they could potentially have a big impact. But I do think the consistency in messaging within this kind of population of scholars is pretty key.
I completely agree with that. I think the other issue, you talked a bit about polarisation. I think we need to be very careful that we're not contributing to that by actually acknowledging uncertainty, acknowledging the nuance in some of this. And I think where you're absolutely right, people often don't pick up the phone and talk to us. Yeah. But I do see some extraordinary press releases going out from academics and from universities, which I think play into a very polarised agenda in a very attention, headline-seeking way. And I don't think that's helpful, and I think we as scientists do need to take some responsibility for what we say, but also for what is being put out effectively in our name. Doesn't guarantee it's all going to be, we're all going to get on, but I think, you know, you kind of have to take responsibility where you can, and I'm not sure we all always do that all of the time. Okay, Lindsay, thank you. We could have gone on for ages. Huge questions. Thank you again.